Welcome back, everyone. I am super thrilled to dive into this analysis with you today. We're tackling a massive, fundamental disruption that's happening literally right now in the cybersecurity world. We're looking at the absolute explosion of artificial intelligence in penetration testing. Now, this isn't just some distant future tech, it's a radical shift in how we secure our digital infrastructure today. Whether you're knee-deep in InfoSec or just trying to wrap your head around the next wave of tech disruption, you really need to see what AI is actually doing on the front lines of network defense and offense.
Okay, let's dive right into this. A lot of folks still think of AI as just, a helpful little chatbot, something that writes your emails or answers trivia. But the reality? It's far more intense. AI is absolutely not stuck in some laboratory experiment anymore. It's already heavily deployed across red teams, bug bounty programs, security operations centers, and threat hunting platforms. It's actively analyzing website weaknesses, generating exploits, and writing some seriously dangerous payloads. Basically, AI is simulating the exact workflows of real human hackers.
So here's the evolutionary timeline we're covering in this explainer today. 1. Traditional pen testing. 2. AI recon capabilities. 3. Finding logic bugs. 4. The threat of AI agents. 5. AI technical limits. And finally, 6. Humans and AI unite. Let's get to it.
Section 1. Traditional pen testing. Let's establish the baseline complexity here.
A lot of people outside the industry think pen testing is just, firing up Kali Linux, mashing a button to run a script, and calling it a day. But a genuine, comprehensive penetration test, it's an incredibly complex, multi-stage operation. It starts with heavy information gathering, hunting down DNS records, subdomains, IPs, leaked GitHub data, just to map out the target. Then comes the vulnerability scanning phase, where a human engineer meticulously configures tools like Nmap, Nessus, and Burp Suite to hunt for SQL injections or weak passwords. If they actually find a flaw, they've got to manually craft an exploit, attempt to elevate privileges, and establish persistence on the network. And finally, the tedious part. They have to sit down and manually write up a massive report detailing CVSS scores, attack paths, and remediation steps. It takes high-level human strategy, patience, and serious operational skill at every single step.
Moving to Section 2, AI recon capabilities. It's all about how AI understands a target compared to that manual legacy process.
So the scariest new feature of AI in cybersecurity isn't just that it can run automated scans faster. No, it's that AI has begun to actually understand a target. Traditional scanners are essentially blind, right? They only look at HTTP responses. They poke a server and just see what bounces back. But large language model AI, it does something entirely different. It can directly read the source code. It literally reads the HTML, the JavaScript, the API docs. If an AI reads a snippet of JavaScript routing to an admin portal, it doesn't just log a URL, it infers the entire backend architecture. It guesses that the server is using Flask, relying on JSON Web Tokens, and utilizing REST APIs. It builds a contextual map of the application, exactly like a human engineer would. Wild, right?
Which brings us to Section 3, finding logic bugs. Let's look at AI's automated discovery.
Now, what's really interesting about this is how AI handles logic vulnerabilities. These are exactly what they sound like, flaws in the actual business logic of an application, rather than just a simple typo in the code. Because they require a real understanding of how a system is supposed to work, traditional automated tools fail miserably here. But AI models? They now actually possess that understanding. Let me give you a concrete example. Say an AI spots an HTTP request for user 1001's profile. Because it understands the concept of user accounts and sequential numbering, it automatically decides, hey, let's test user 1002's profile. If the server grants access without checking permissions, boom. The AI instantly flags this as an insecure direct object reference vulnerability or an IDOR. The AI recognized a logical boundary and intentionally crossed it just to see what would happen.
And once it actually finds a vulnerability, AI can absolutely attack it. Historically, an engineer had to carefully handcraft payloads to bypass a specific server's defenses. Today, AI can directly generate complex payloads for cross-site scripting, SQL injections, server-side template injections, you name it, even deserialization attacks. But here is the real kicker. These payloads are adaptive. If the AI sends an SQL injection and the server blocks it with a specific error message, the AI reads that error, dynamically modifies its attack strategy on the fly, and generates a morphed payload to bypass the filter on the second try. The attack is literally adapting in real time.
All right, Section 4, the threat of AI agents. This is where we get into autonomous operations.
Up until now, you might still be picturing a human typing prompts into a chat window to get these payloads, right? But we have evolved way past that. We really need to clearly define what an AI agent is. An AI agent is a system that doesn't just answer your questions. It is an AI given the autonomy to actually use tools. It can autonomously open a browser window, it can autonomously run Nmap, it can call the Burp API, it can even write and execute its own Python scripts to test an exploit. It functions incredibly close to a real, living, breathing, autonomous hacker.
And this brilliantly illustrates what that looks like in practice. An AI pen test agent's workflow isn't just one isolated action. It's a chained sequence. Step 1. The AI autonomously scans the website and identifies a login page. Step 2. Without any human intervention at all, it tests a battery of SQL injections and weak passwords. Step 3. It successfully exploits a flaw and extracts a security token. And Step 4. It uses that token to attempt lateral movement deeper into the network. This entire, highly sophisticated attack path can be completely automated. Past botnets were just dumb packets flooding a server. Future AI bots, they will autonomously hunt, attack, mutate their payloads, and actively evade detection.
But let's pause for Section 5, AI Technical Limits. Let's talk about the false positive problem.
Now, take a breath. I know this sounds like some sci-fi thriller where machines just completely take over, but for all its incredible capabilities, AI is absolutely not about to replace human pen testers overnight. Why? Well, because AI still fundamentally struggles to understand true business rules. Yeah, sure, it can figure out basic logic like sequential user IDs, but it fails spectacularly at complex, real-world business logic. Take a banking system, for example. The intricate, multi-step logic of transferring funds, verifying complex holds, and checking human-designed compliance thresholds, that is utterly baffling to a scanner, even an AI one. Because it doesn't truly grasp these complex processes, AI is highly prone to misinterpreting normal application behavior as a vulnerability. This generates massive amounts of super frustrating false positives that just waste engineers' time. Because of this, the absolute highest levels of cybersecurity remain firmly in human hands. AI cannot effectively execute highly nuanced social engineering campaigns. It just lacks the creative intuition required for complex internal network pen testing or mapping out intricate privilege escalation designs within Active Directory. And when it comes to true zero-day research, discovering completely novel vulnerabilities that have literally never been seen before, human mastery, intuition, and abstract problem-solving are still completely irreplaceable.
And that brings us to Section 6, Humans and AI Unite. Welcome to the Super Red Team.
So, what we are seeing emerge is what industry experts call the Super Red Team. It's essentially a perfect division of labor. The human engineer takes on the role of the master strategist. The human is responsible for understanding the complex business logic, designing the overarching attack path, and really seeing the big picture. Meanwhile, the AI takes over the execution. The AI handles the endless scanning, the massive data analysis, dynamic payload generation, and rapid automated testing. By pairing human strategic brilliance with an AI's relentless execution speed, the efficiency of penetration testing absolutely skyrockets.
So the crucial point here is that AI is fundamentally altering the entire barrier to entry in cybersecurity. As this quote suggests, we are rapidly moving toward a world where a hacker's most valuable skill isn't necessarily writing raw exploit code from memory, it's knowing how to effectively prompt and command an AI agent to do it for them. This transition is taking place across the entire security landscape, from SOC and EDR to threat hunting and malware analysis. Literally everything is becoming AI-driven.
Which leaves us with this final provocative thought to wrap up our explainer today. The core challenge of cybersecurity is no longer whether an AI can hack a website. It can. The real question is, in the future, who can find vulnerabilities faster than the AI? It's a full-on race between human AI defensive teams and human AI offensive teams. If you want to stay ahead of this curve, really understand these dynamics, and master the art of collaborating with AI, make sure you hit that subscribe button. We're going to continue to break down the most vital shifts in network defense and attack strategies right here. Keep learning, stay focused, and I'll see you in the next analysis.